Assalamu alaikum wa rahmatullahi wa barakatuh. Peace be upon you all and welcome to the channel. In this video we will continue with the linked list, particularly the constructor of a linked list as well as its methods. So this will be part 2 of the previous video. As you can see, I left what we discussed in the previous lecture simply to remember where we stopped so that I can continue with what is remaining. But before we begin, Bismillah ar-Rahman ar-Rahim, Alhamdulillah Rabbil Alameen, wassalatu wassalamu ala ashraf al-anbiya'i wal-mursaleen, Sayyidina Muhammad, وعلى آله وصحبه ومن تبعهم بإحسان إلى يوم الدين وارض اللهم عنا معهم أجمعين اللهم آمين اللهم صل على محمد وعلى آل محمد كما صليت على إبراهيم وعلى آل إبراهيم وبارك على محمد وعلى آل محمد كما باركت على إبراهيم وعلى آل إبراهيم في العالمين إنك حميد مجيد. We begin in the name of Allah, the most merciful in this life and in the hereafter. We thank Him for all of His blessings that He has bestowed upon us, for they are innumerable. And we pray that we follow in the footsteps of Prophet Muhammad, peace be upon him, and his fellow companions. Amen. We also ask for prayers and blessings to be bestowed upon Prophet Muhammad, peace be upon him, and his followers, as they were bestowed upon Prophet Ibrahim, peace be upon him, and his followers. To recapitulate quickly what we discussed previously, we discussed the instantiation of a linked list, an empty linked list to be precise, using the empty constructor or the non-parameterized constructor to be accurate, as well as the instantiation of an instantly populated linked list using the parameterized constructor. We saw the addition of elements to the list, the display of the list, the retrieval of the first element and the last element, the removal or deletion of the first and last elements, the addition of the first and last elements, as well as the size of the linked list, which is the same method as the one present in the ArrayList class, as well as the contains Boolean method to check and see if a particular element exists within the list. For this video, I will focus on the parameterized constructor rather than the non-parameterized constructor, simply because the title of the video is Constructor and Methods, so I would like to cover a constructor and methods. Since the focus in the previous lecture was mainly on this constructor, I will focus on this constructor instead. The reason I did not create a dedicated lecture to the constructors as I did with the array list is because now I feel that you have developed the necessary skills to be able to actually investigate the documentation and understand how to view the constructor of a class and instantiate its object accordingly. I will delete this one and focus on this one for today. I will 21. I will leave these for reference. I actually do not need this because I already have it here. Just to review quickly before we continue, this is the parameterized constructor that constructs a list containing the elements of the specified collection in the order they are returned by the collection's iterator, basically in the order that you pass here. And as you can see, it accepts a collection. Remember, a collection, not an array. Arrays, at least in Java, are not part of the collection framework. The collection framework contains classes that enable dynamic growth and reduction. The size of the collection can grow when necessary or shrink when necessary. Arrays are static. Once you have instantiated them, they can no longer change unless you actively design a dynamic array, as we have seen in a previous video. So remember, it accepts a collection, and since a collection is technically an interface, you can pass any subclass of an interface or a class that implements the interface collection. I will keep this because I will need it for the methods. Okay, let us see what other methods we have. Bismillah ar-Rahman ar-Rahim. Okay, we have get first, get last, remove last, add first, add last, contains, and size. And we also covered add. Did we cover remove? No, we did not cover remove. Okay, let us read the description and see the functionality of the remove method. Or we can read it from here. Removes the first occurrence of the specified element from this list if it is present. If this list does not contain the element, it is unchanged. Okay, let us test this and see. And here it returns a Boolean value, true if the element that was removed was actually contained, and false if the element was absent to begin with. Okay, so here we have 4, 5, and 6. Element removal. Remember, this does not necessarily designate if it is the first element or the last element. It is simply an element. It could be in the middle of the list, the beginning of the list, or at the end of the list. Let us remove this element and see the new and display the new list. Should probably title this as list display. What does it accept? It accepts an object, so basically an element, the element to be removed if present. So it does not remove based on an index, it removes based on the element itself. List dot remove. Let us remove this element. Okay, then display the list. System.out.println list. Okay. Bismillah ar-Rahman ar-Rahim. Index out of bounds, index 4, size 3. And as you can see here, it is not using the correct method. I have been working with JavaScript for quite a while. That is why I use the term function instead of method. There are no differences, slight differences, but that is it truly. Perhaps we have two methods with the same title or the same signature. Remove. Okay. So this one removes based on the index. It removes the element at the specified position or the specified index. Let us tackle this method first, then return to the previous one. So instead, here we have index 0, index 1, and index 2. So let us remove the element at index 2. I will add the indexes here or indices, however you wish to pronounce them, for simplicity. Here I can add index like so. There. So let us remove element removal with index. So this should print, let us remove index 1. So this should print 4 and 6 because this will be removed. Let us confirm. Bismillah ar-Rahman ar-Rahim. 4 and 6, perfect. So the element at the particular index has been removed. So I will remove this from compilation for now. Let us return to the other function. Oh, we have too many removes here. Okay. Let us return to the first one we saw. There. Okay. Let us see if I can trick the system into actually selecting the proper method this time. Remove this one. Again, it keeps choosing. Well, the reason it chooses this is because these are numerical values. So it believes that I am using indexes. If these were a different data type, for example, a string, it would not confuse itself. So what we can do is trick the system by storing the return type in a Boolean variable. We can say Boolean contains 4, for example. Change contains, okay. Must be an object, is the object, blah, 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 okay. Wonder if I can change this. Okay, the decimal seemed to have changed it. Okay, I will check and see how the integer class can be used. It should. Oh, that is why. Okay. So the wrapper classes do not extend the object class. Okay. Hold on, I will check and see how we can convert a numerical value to an element of the object class. Well, let me try this. Object num is equal to list dot get element 0 dot without the dot, sorry. And then okay. Will this work? Okay, hold on, let us try this. I did not even need to cast it. Okay, so this should display 5 and 6. Oh, okay, it worked. Lovely. That is strange. I wonder how you can trick the system into recognizing this is an object. Because as far as I know, wrapper classes are objects. That is why they exist. So they convert the primitive data types into, what are they called again? Into reference classes or reference data types. Okay, so here is what I did. I instantiated an object of the object class and retrieved this particular element through the get method here, and I used the index. Then I removed it from the list like so, then displayed the list. And as you can see from the output, it removed number 4. So this removes the actual element of the list. Let me see if I can cast it inside here. Object 4. Okay, let me see if this will work. Bismillah ar-Rahman ar-Rahim. Okay, it worked. So I simply need to cast it within the method here to prevent the compiler from being confused between a numerical value as an index and a numerical value as an actual object. Okay. Yeah, you see, I teach this course, but I also learn through teaching it, which is why I love this course, because I learn as I teach. So not only am I helping others learn Java, I am actually helping myself because I learn, grow, and develop as well. Okay, so we do not need this anymore. We covered removal. This is used to remove an element within the list regardless of its location. However, if you wish to remove elements with a specific location, particularly the ending or the beginning, you can use these instead. How about displaying the Boolean return value to see if this will actually display true or false? So what we can do here, I will create a new statement. List.remove object 4. Here we will say, does the list contain element 4? So this should return true. And there you have it. But it also has been removed. So I probably should revert this to the past tense. Did the list contain element 4? And then we display the list. It did, before it was removed. Okay. How about if we try to remove element 7 and then display the list? This should display 4, 5, and 6 because nothing will be removed since this does not exist here. So this will yield false. And as you can see, the list never contained 7. Perfect. I will remove this from compilation. And this as well. At least for now, we will need it later. What else can we use? Add all. Appends all of the elements in the specified collection to the end of this list in the order that they are returned by the specified collections iterator. This has been seen also in the ArrayList class, where we add an entire collection to the ArrayList. Here, take note that it adds it at the end of the list. Here, it requires an index because it adds the collection to the specified position, which means that it will shift the elements as necessary, and it shifts it to the right. So let us try both methods, and remember these accept a collection. So we can add perhaps another linked list or an array list to this linked list object we are using. So let us do so. Collection addition at end. Let us create an array list of integers as well. I will call this, oh man, I hate these stupid importation. Okay, and I will call this array is equal to new array list blah 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 blah. Oh, I wanted to discuss this. I am sorry, I wanted to discuss this unless I discussed it in the previous video. If I did, I apologize, but I will discuss it here just to be safe. Okay, never mind then. Oh yeah, it does add it here. Okay. Okay. I actually forgot what I wish to discuss. Never mind then. Let us return to add all. Okay. So this constructor uses the add all method to simply add this collection to the end of this list. Here, I will copy this and add 1, 2, 3. Then I will add list dot add all, and I will add this list here. Then I will display it, so the new list should have 4, 5, 6, 1, 2, 3. Because remember, this method adds the collection at the end of the list. Let us test it. 4, 5, 6, 1, 2, 3. Perfect. What if I wish to push all of these to the right and have 1, 2, 3 appear before 4, 5, 6, before 4, pun intended. Remember, this one pushes the elements to the right. So if I wish to add these to the left of these, I will have to add these at index 0 so that these 3 push these 3 to the right, like so. 1, 2, 3, and then 1, 2, 3, like so. And I will delete this. So this is the desired output. Let us actually create it. Collection addition with index. I will place this here actually. And remove this from compilation. Here, list dot add all 0 and array. Now let us see the output for this one here. And as you can see, it worked as expected, thankfully, because this method pushes the elements or shifts the elements to the right. If it was shifting the elements to the left, we would have to arrange the index accordingly. We do not need this anymore. Let us venture forth and see what else we can cover. Clear, as the name suggests or implies, it empties the list. Let us create it here. List clearing deletes, or we can call it list emptying. That will be list.clear. This should print nothing because we are clearing it. I will move the display statement here. And as you can see, it is empty because we have emptied the list or cleared the list. Okay, I will remove this from compilation. Let us move on to another method. As I mentioned previously, we will not cover everything. Did we use the get method? Oh, I believe we only used get first and get last. I did use this a moment ago, but I will use it again. This is the same method we encountered in array lists as well. That is probably why I did not explain it when I used it here. But for the sake of comprehension, let us cover this method accordingly. Returns the element at the specified position or the specified index. I will push this downwards. Element retrieval with index. So we are not retrieving the first or the last. We are retrieving any element, whether it is the first, the last, or an element within the list or between the first and the last. I will remove this from compilation for now because we do not use it. Collection creation. This is for the add all method. Let us say we wish to obtain element number 5, which is in the middle of the list. So here we will simply, we do not need this, list.get, and element 5 is at index number 1, so we will pass 1. Remember, we are using the index here, not the element. So this should print 5. There you have it. We can also use this to obtain the first element or the last element. Let us say get 0, so this will obtain the element at index 0. For the last element, here we can simply say 2, or to place it mathematically, since the list could be larger than 3 elements, we can simply say list dot size -1. Because remember, the index of the last element is always the size of the array, or the size of the collection, -1. However, with arrays, we do not refer to it as size, we refer to it as length. And there you have it. This, of course, is fixed. It will obtain the last element for any linked list, regardless of its size. Or we can simply use 2 here, since we already know the last index is 2. Either or work perfectly, which is what we want. Okay, let us see what else we can use. The set method replaces the element at the specified position with the specified element. So the element being passed here will replace the element located at this index. Let us test it. Here we can say element substitution, the same as with football. How about replacing 5 with 7? Okay, let us try this. List dot set. What is the index of the element we wish to replace? What we wish to replace is 5 and at index 1. What do we wish to replace the element located at index 1 with? We wish to replace it with element 7. We wish to replace the element located at index 1 with element 7. So the new list, if we display it like so, will give us 4, 7, and 6. This will be the output. Bismillah ar-Rahman ar-Rahim. And there you have it. So we can replace elements using their index. Perfect. What else do we have here? Inserts the specified element at the specified position, and it shifts the element to the right. We did cover addition, but we covered this form of addition which adds it at the end of the list. This adds the element at the specified index, and when it is added, it shifts the elements currently present at that index to the right. So let us test that. Element addition with index. How about adding a 7 between 5 and 6? So if I wish to add a 7 between 5 and 6, which index do I need to use or pass as an argument? Remember, this method pushes the elements to the right. So if I wish to add between 5 and 6, I actually need to push 6 to the right. So it is pushed like so. And this becomes like so. So I need to add the element 7 at index 2 to push 6 to the right. So here it will be list.add index 2, and the element that will be added is 7. So this output will be 4, 5, 7, and 6. Let us test it. And there we have it, 4, 5, 7, 6. Excellent. Removes the element at the specified position. We removed the first and the last elements, but we did not remove based on index, which is more flexible because you can remove any element with that method. As opposed to remove first and remove last, they only remove the first element or the last element respectively. Element removal with index. So I will remove this from compilation. Actually, I will leave. No, there is no need to keep it. Let us remove it from the list. Let us say I wish to remove 6 from the list. List dot, I was writing at remove the element at index 2. This will be the output because this will be removed. Bismillah ar-Rahman ar-Rahim. And there we have it. Perfect. tells if the argument is index. These are private, so we cannot access them. Returns the non-null node at the specified index. Okay, I never tested this before. Let us test this and see. It returns the node, which is basically the reference or the pointer at the specified element index. Okay, so it is node index list dot node list dot node. We cannot access it. Probably because it is, that is why, because it is package private, or was it private package? No, package private. So we cannot access this. Okay. Index of returns the index of the first occurrence of the specified element in this list, or -1 if this list does not contain the element. Here, this is the reciprocal of remove, where it returns true or false. This returns either the index or -1. Perhaps it is not an actual reciprocal, but closer to it. Okay. Index, element index retrieval. Here we are retrieving the index this time, not the element. So let us display list dot index of object. So I am casting it here. Let us say 5. The index of element 5 is 1. So this should be 1. Okay. As you can see here. Element index. Like so. Oh. I am adding this to the incorrect portion. That is the correct portion. Element index is 1. But what if I pass an element that does not exist within the list? So the output should be -1. Let us pass 7. So this should return -1. And since arrays or lists begin with index 0, if this is negative, then it is moving to the left-hand side of the array or the collection, indicating that it actually does not exist, because indexes or indices are always positive, which means that they always exist if they are positive. If it is negative, the index is actually non-existent, or rather the element itself at that index is non-existent. Why does it say first occurrence? We also saw the first occurrence. I do not know if we saw it in the previous lecture, but here it states, this one, the first occurrence. Lists, whether they are linked lists or array lists, allow for duplication. So we can have 2 4s without an issue. However, this will obtain the first occurrence, not the second occurrence. So this, for example, will retrieve 0, not 1, because it looks at the first occurrence. So let us test this. Perfect. The same applies for this method. If you have 2 duplicates or 3 duplicates or multiple duplicates, it will always remove the first occurrence of that element. Why the creators are emphasizing first? Because lists allow for the existence of duplicate values. Later on, when we cover, inshallah, bi'idhnillah, and God willing, sets, particularly hash sets, duplicates are forbidden, which is why if you wish to convert a linked list or an array list to or not necessarily convert it, but if you wish to remove duplicates from an array list or a linked list, you can convert them to a hash set, and the set will automatically remove duplicates for you. We will see that inshallah bi'idhnillah, and God willing, once we cover sets bi'idhnillah. But now I am prioritizing this because linked lists are important if you wish to understand hash tables, which are important for you to understand hash maps. Hence why I decided to start with arrays, then array lists, then linked lists, then move on to at least what I believe is the most important topic in data structures, which is hash maps. Other than array lists, hash maps will definitely be encountered either at your workplace or in an academic setting. Array lists and hash maps are quite common, followed by hash sets. Honestly, I have not seen trees or graphs at the workplace or in the academic setting, possibly because they are not that common. I do not wish to say common because it depends on the cases they are used for, obviously. At the workplace, I have encountered array lists, definitely, as well as hash maps. Rarely have I encountered hash sets, but I did encounter them, which is why I would like to cover them, because I encountered them at the workplace. So I wish for you to be ready for a professional setting. Then, once we cover the essentials, we can build upon that foundation with other types of maps and sets, such as enum map or enum sets, and then trees and graphs, bi'ithnillah, and God willing. So I decided, instead of maintaining a chronological order of finishing all the lists, then moving on to all the maps, finishing all the maps, and then moving on to sets, I will focus on the commonly encountered ones, and then we can add to the sub-series later on, bi'idhnillah, and God willing. Let us see what else is next. Last index of returns the index of the last occurrence of the specified element in this list, or -1 if this does not exist. Here, how many occurrences do we have? 2. The first and the last. Last occurrence index retrieval. I will copy this, paste it here. Last index of 4. So this should be 1 now. Well, actually, let us try 7 firstly, so we can see the -1, which does not exist here, obviously. Oh, I forgot to remove this from compilation. I apologize. Perfect. Now let us return this to 4. This should be 1 now, because this is the last occurrence. Perfect. Let us test this with a third 4. So this will be index 4. So the last occurrence of these 3 duplicates would be actually here 2 now, not 1. Perfect. Excellent. Okay. What else do we have here? Peak retrieves but does not remove the first element of this list. Returns the head of this list or null if the list is empty. Okay. Let us test this and see. List peeking. Peeking, oh man. Such a silly name. List.peek. So this should obtain the first element, which is 4. And there we have it. We also have this one, retrieves but does not remove the first element of this list. However, here is the difference between peek and element. If the list is empty for peek, it returns null. However, if the list is empty here, it will return an exception because of the algorithm utilized in both methods. So be careful of which element, of which method you use. If you are using this one, ensure that you are catching or handling this exception. This does not require exception handling because it returns null if it is empty. Without exception handling for empty lists. So I will copy this, paste it here. Requires exception handling for empty lists. I will remove this for now. Let us test this to see that it actually returns null with an empty list. So here I will say list.clear. And as you can see, it already detected that it will return null. There. Okay, so I will return this here, like so. Actually, I will remove it, just in case this and this causes confusion, because obviously if this method is being invoked, it will return nothing. So here it will return null. I have an idea to resolve the matter. Hold on. There, perfect. Okay, now let us test it here now. What was it? Control Alt T? I forgot how to indent properly in IntelliJ. So this is element. This should also return 4. First element retrieval. I will add it here as well. Where is it? First element retrieval. There we go. Okay, let us test this. Bismillah ar-Rahman ar-Rahim. 4. But watch what happens when this takes place. This will trigger or throws an exception. Element. Here we go. Will always fail, which is what we want. We wish to trigger exactly. That is what we need. Perfect. By the way, most of the methods I am revealing here, I am unfamiliar with, but thankfully the documentation is clear. Sometimes the documentation for Java is annoying. It is difficult to understand. Honestly, I believe programmers need to focus on developing their skills, their rhetorical skills, rather than their programmatic skills, or focus on developing both simultaneously. Okay. What about this method, pull, which we will encounter, inshallah, I believe in JavaScript, if I recall correctly. retrieves and removes the head or the first element. So it retrieves it for you as a return type, but it removes it. So if you wish to store the first element of the list in a variable while removing it from the list, this is the method you need to use. And here we can add without removal to emphasize the point. Okay. First element retrieval with removal now. With removal. Okay. So what we can do is simply say integer number is equal to list.pull and then display the list. Without this, obviously. Remember, this will remove the first element. So the entire list will be the double 4s and 5, ultimately ending with 6. Like so. Let us test it. Bismillah ar-Rahman ar-Rahim. There you have it. We can also print the number, element removed, so it removed 4 and left the rest of the list. What else do we have here? Retrieves and removes the head or the first element of this list. Again, this returns null if the list is empty. This one does not return null. It actually throws or triggers an exception if the list is empty. Without exception handling, yes, that is what I want. Okay. Then I will copy this, paste it here with removal, but it requires exception handling for empty lists. Okay. So this is remove, then element removed, followed by, well, actually, before we test this, let us test this with an empty list. So we can say list.clear, then copy this, paste it here, and then display the list here like so. This should display null. And as you can see, it detected that it will always be null. Oh, I know, hold on. We can do this instead, yes. And there you have it. Okay, perfect. Let us test this without triggering the exception to ensure that everything is functioning properly. Perfect. Now let us try it with the exception now, or with an empty list, I apologize. List.clear. Then we say here list.remove. This should throws an exception, which I believe is no such element. Yeah, no such element exception. Perfect. Okay, oh man, this is a long list. Perhaps I will create part 3. Yeah, because honestly, I am growing rather fatigued because this tends to be the time when I sleep. So I'll probably continue this in part 3 inshallah bi'idhnillah and God willing. So I will stop here. We covered quite a lot actually, and we will continue from offer and onwards. Possibly part 3 will be much shorter because I do not believe we have that much left to cover. So I will leave that for part 3 inshallah bi'idhnillah and God willing. I hope that is it for this video. I hope this lecture was helpful and beneficial to you all. Enjoy the rest of your day, everyone. Be safe, take care, and peace be upon you all. Wassalamu alaikum wa rahmatullahi wa barakatuh. Allahumma salli ala Muhammad wa ala ali Muhammad kama sallaita ala Ibrahim wa ala ali Ibrahim wa barik ala Muhammad wa ala ali Muhammad kama barakta ala Ibrahim wa ala ali Ibrahim fil alamin إنك حميد مجيد